This is section 3.2. We are doing solving equations using multiplication and division properties of equality. All right, just like with addition and subtraction properties of equality, if I start with a basic equation and I multiply the same thing by both sides, the equation will stay in balance. So if I had something like x over m equals n, to get the x alone, I would have to do what to both sides of the equation? Go, Chloe. What am I doing to both sides of the equation if I have x over m equals n, if I want to get x alone?
You divide by x?
No, x stays there. Yep.
You multiply by m.
Multiply what by m?
Both sides.
Both sides by m. Now notice I want it lined up with the numerator. So how did I determine that? Remember we said before, opposite operations. This, what does this line mean, this fraction bar? Division. So the opposite operation would be multiplication. And then we could cross cancel. And notice I want m's. When you multiply from numerator, when you cross cancel numerator to denominator. So that's going to matter. And here's x is equal to, we put it in alpha order, mn. Are there questions? Okay. So, when doing, now I want to talk to you about your fractions. When you are on like lined paper, right? This is what I want you to do to keep you successful. Let's say this is my lined paper, and you are writing a fraction. I want no more than one number on a line. I want to see x, division bar on the line, 3 equals 4. So that way it keeps you lined up. What am I going to do to get the x alone? Chloe.
You multiply by 3.
And notice I put the multiplication and I line it up with the numerator. Why? Because I want to cross cancel. And I can't cross cancel if they're both in the denominator. Do you understand? Where you place your numbers, numerator, denominator, is very important. So this is really the same thing as to...
Please excuse the interruption. Students who have not received their locker shaft.
Okay, so I'm going to cross cancel, and then I'm left with x is equal to 12. Are there any questions? Okay, so let's do, you guys, why don't you do number 3? Go. I don't want to see any squishing of 2 numbers per line. Whoops. Do you want that back? You guys are doing number 3. Give me a thumbs up when you're done. And now I'm left with x is equal to, I'm left with m is equal to 50. Any questions? All right, so let's go on to division property of equality. If A equals B, and I divide both sides by C. Now, I want to, so if I divide, it can start something like this. Yeah. If x times m equals n, we can divide both sides by m. I want you to think of division property. Sometimes it's also considered the multiplication property. So let's just take an example like 4x equals 28. 4x equals 28. I can show this in a couple different ways. I can divide both sides by 4, and x equals 7, right? I would say that's the division property of equality. But isn't this also the same division property of equality? Isn't this the same as multiplying by 1/4 on both sides? So we also call the division property of equality the multiplication property of equality. So now I have, what happens is, these cross cancel, I'm left with x, and here I'm left with 7. Does that make sense? So division property of equality can also be called multiplication property of equality. Are you guys good with that? All right, so let's try and practice one. All right, what am I going to do to the 5x? What am I going to do to this equation? Somebody I haven't heard from. How about right there? What's your name?
Brianne.
Brianne.
So you would have to divide 5 for both sides.
5 on both sides. And we would get
X equals 4.
x equals 4. Is everybody remembering what to do? Okay, let's jump down to number 4. Number 4. What do I do first? How about Isabel? Divide by 4 on both sides. And we are left with k equals, just say what's there. 18 over 4, right? It's not a whole number, so you can leave it like that, but I want you to reduce it. What number divides into both parts? 2. So when I divide both sides, numerator and denominator, I end up with 9 over 2. I love improper fractions. I prefer improper fractions. Don't spend the time. Just reduce it. Is everybody clear? All right, so now let's go to something a little bit. So, let's see. Isolate the variable, same operation on both sides. To undo an operation, perform the opposite operation. So, right, we're going to add. When we add, we're going to subtract. When we subtract, we're going to multiply. When we see subtraction, when we see multiplication, we are going to divide. And when we see division, we're going to multiply. Is everybody clear on that? Okay, so I want to move on to, does everybody remember how to multiply decimals? Okay, 2 more questions. Let's try number 2. What am I doing? Multiplying by 3 and 2 tenths on both sides, and we get x equals, I do it right here. I do my multiplication. It's 0, carry the 1, it's 15, 16. And I have 1 decimal digit, so I just keep it visual for myself. So is everybody remembering how to multiply the decimals?
Yes.
Okay, let's go on to a fraction problem. Okay, let me go back first to this fraction problem. We'll come back here. I've already talked about the answers. Okay, let's look at number 7. Or let's look at number 5. What would I do first? Yes, this is a little tricky, number 5.
Divide both sides by 5.
Okay, so if I'm, yes.
You would multiply both sides by 3.
You could do this in a number of ways. What if you have a fraction, turn the other side into a fraction? What would 5 be as a fraction? 5 over 1. So what do I do to get rid of the whole fraction? What's the opposite?
Multiply by 3 over 2.
Well, no. Close. You need to get x alone. So multiply by what? What do you want to get rid of? We're going to multiply by 1 over 5. 1 over 5. Okay? Now over here, I'm going to be left with 1s, right? And 1 times x is what? And then over here, I'm left with 2 over 15. Is everybody remembering how to do that?
Yes.
What would we do on number 6? Chloe?
Number 6, you would multiply by 5 over 2.
Multiply both sides by 5 over 2. Multiplication property of equality. I can do anything to an equation. Now what this does is leaves me with 1a, and we are left with negative times positive is a negative 5/8. Okay, are there any questions? I'm going to put this last bit, if you go up to 10 and 16, 10 and... All right, so now we're going to do our word problems. Write an equation that relates to the unknown lengths of the area. Area formula for a rectangle would be area equals length times width. So I'm just writing 6x equals 72. And then I get, I'm going to use my property of equality, divide both sides by 6. And we are left with x equals 12. The formula for a parallelogram is area equals base times height. So my base is 8, my height is n, and then we solve using our inverse operations, and we are left with n equals 9 centimeters. Make sure you use the units, and that is it for our lessons.